So we're recording now. So, once again, do any of y'all have questions? No questions? All right. In that case, what would you like me to do? I mean, would you like me to go over those AP problems, or would you like to do something? Or go
So
over?
do we know exactly what she's going to put on the test?
No. I don't think we know what's going to be on the test. Exactly, but I feel like the AP problems are good just because that's what we did last time on the test. So, do you guys want to try doing that?
Yeah, sure.
MG, can you like pick out the hard ones in it?
I haven't done it yet, so
All right.
they're all pretty much the same level of difficulty. And if I'm being completely honest, these problems you should be able to do in your head, most of them. Try it, and obviously you might have to write down one or two things. To make it a bit more interactive and to really test your knowledge, what I'll try and do is I'll ask you all to walk through the problem rather than me talking through all of them. I'd rather you guys try, because the more you try and explain it, I feel like you'll have a better understanding. All right. And if you're stuck, there's no shame in that. There's absolutely no shame. I get stuck all the time. Everyone gets stuck. It's part of learning process. So don't feel bad about that. Can you guys see my screen?
Yeah.
Okay, good.
Yeah, we can see it.
All right. So who wants to try the first question? Even like I've never seen this before, no one's ever seen this before. Who just wants to try it?
I don't mind trying.
All right, go ahead.
So f is a continuous function defined for all real numbers, and if the maximum value of f of x is 5 and the minimum value of f of x is -7, then which of the following must be true? So 3 has to be true, because if you're taking the absolute value, then it can be negative, so then 0 would be the next smallest.
Can I make a suggestion? Whenever you see a problem like this, what I'd want you to do is immediately just draw it out. So the minimum of f of x is -7. It might look something like this. Okay, let's just say it looks something like this. I don't know. But this right here is -7, and this right here is +5, right? Okay.
Yeah. It says the maximum value of f of absolute value of f of x is 5. So that's not true, because if you look at number 2, then you can have the maximum, if it's -7 and then you have the absolute value, then it becomes 7. So the maximum is 7, not 5. So it should be D.
So number 2 is true, right?
Yeah.
Okay. And why? I actually, I'm still trying to figure this out. Actually, I can't. So I'm trying to visualize what the f of absolute value of x would be, right? Try to think about this. So what does this mean? The maximum value of f of absolute value of x.
Wouldn't that just be like all of the x values on the right side of the y-axis only? Because it can't go on the left side of the y-axis.
You're right. You're absolutely right. Exactly. So basically it would be everything on this side. But what's important here is that I've drawn only one possibility. The other possibility could be that we end up at 5 and then we end up at -7 here. So this might be -7 here, and this might be +5 here. So here's the problem. The maximum value of f of absolute value of x is 5. That's not necessarily true. Actually, is it true? It's not necessarily true, right?
I don't think you can like guarantee it.
You can't guarantee that. You can't guarantee it.
Because you don't know the function, so you don't know like what x values are true, but you only know what y values are true.
I think that's what Zachary was saying, right, Zachary?
Yeah, because you know that you can have a maximum of 7 if you're taking absolute value, because the minimum is -7.
Okay, I see. So 1 is eliminated. That means immediately we can cancel this one, and this one. Now, is 3 one of them? And that's the question. So the minimum value of f of absolute value of x is 0.
I don't think that works either for the same reason. Like we don't know where it is.
Exactly. So as in this example right here, the minimum value of the f of absolute value of x might be -7, right? So that's why this one's false. So the answer would then be B. Does someone have the
But
solutions?
why is it false? The
Okay.
third one.
Third one, why is it false? Because the f of the absolute value of x, the input is always going to be positive. So anything on this side does not count, essentially. So anything on this side, everything on the right side of the y-axis counts, including the y-axis. The minimum value of this function is not necessarily 0. It could be -7, as we can see here. So the main thing for these is if you can find one counterexample, think about a special case. If you can find one counterexample, that'll give you your answer. So does anyone have the solutions open? I just want to make sure that we're doing.
Yeah, it's B. I
It's
just
B?
checked.
Okay, good. All right.
So are these the type of problems we're gonna see on the test tomorrow?
Probably. I think so. And this was probably one of the harder ones, if I'm going to be honest, because that took me a while to think through. And you might actually, these are probably the more types of problems you'll see on the AP exam as well. So
Yeah, okay.
just get used to it, is I'd say the main thing right now. But 2 is the only one we can guarantee, so that's good. Okay. All right. Let me go and clear this. Do we have any more questions on this first one? I know that one was a pretty difficult one to start off with, but okay.
Hey MG, I have a question on how to take the test. You know how we don't end up getting enough time to finish the test. How do you recommend we take it? What should we do? Constructive response first, or
I do multiple choice always first, because you're getting more credit from the multiple choice questions. Not necessarily, okay, but because it takes less time and you can get more questions in.
Okay. And
ideally, you should be doing the drawings and stuff very quickly. It's a rough sketch, a very rough sketch, and all of the work is being done up here. The more you write on paper on the multiple choice, the more you're digging your own grave. On the test, on the multiple choice. On the free response, you want to write as much as possible. That's the other thing to keep. Okay, who wants to try number 2? And if you want to, you should be able to annotate my screen, and feel free to do that. Yes.
You can do it in your head, can't you? Really quickly.
Yeah. Okay.
I think I know the answer, but.
Do you want to try and explain it? Just walk us through how you would do it in your head.
Okay. Well, if it's f of g of x, then you know that every x value in f of x is substituted with g of x. And so if f of g of x is natural log of x squared plus 4, and f of x is a natural log of x squared, then wouldn't the answer be E, because x plus 2 squared is x squared plus 4?
Is it though? What is x plus 2 the quantity squared?
X plus 2 is, oh wait, no, never mind.
So what would the answer be? You were on the right track. What's the answer though?
Yeah. Square root of x squared plus 4. Yeah.
It would be C, right? I believe it would be C. Mm-hmm. Is that correct, Alina? Sorry, I didn't mean to startle you. Okay.
Yeah, it is. Sorry.
Okay, good. All right. So see how quickly we did that? That's what you need to be doing in your head. You don't have time to write this out. Number 3, what is the domain of the function f given by fx equals root x squared minus 4 over x minus 3? All right, what are the 2 things we need to watch out for?
Or when the denominator equals 0.
Yep, and then what about the radical up here? What's important about the radical?
Vertical asymptote.
That it doesn't equal anything negative.
Yes, that it doesn't equal anything negative, and that it doesn't equal 0. Because if it equals 0, then it becomes a whole, right? So, essentially, and you'd be doing this in your head, but one of them is obviously x does not equal 3. All right, and you can write this down if you want to, but be really quick about it. X does not equal 3. That's the first thing for sure. The second thing we know is that x squared minus 4, and once again, this I'm doing in my head. X squared minus 4 has to be greater than 0. It can't be equal to 0, even though the function itself would work. Actually, it can be greater than or equal to 0. It depends on what x is. We'll get there. So x squared minus 4 is greater than or equal to 0. Because if it's equal to 0, then the function is just 0. It's still defined. So that means x squared is greater than or equal to 4, meaning x is greater than or equal to plus or minus 2. But that doesn't make sense, so one of these is wrong. So then what you have to do is you have to draw yourself a little number line, think -2, +2. If I plug in 0 here, this doesn't work. If I plug in -3, that's 9 minus 4, that works. If I plug in +3, that works. Do you understand what I did with this number line thing here? Or did I go too fast? I probably went too fast, but let me know. Do you know why I did this? Because whenever you take inequalities with quadratics, you're going to end up with a weird answer, because this ends up looking like this. X squared is greater than or equal to 4, meaning x squared is greater than or equal to plus or minus 2. But obviously that makes no sense. That makes no sense. So what I do is I take my two special values, 2 and -2, and then I look at the intervals. Okay, so I'm going to test a value between -2 and +2. Now, if I test 0, 0 squared minus 4 is negative, so it doesn't work because it gives me a negative value. However, this interval from -∞ to -2, and the interval +2 to infinity work. These two intervals work. That's why I know that essentially what it's saying is, oh, okay, that's interesting. They've written it as absolute value of x. Okay, that means that absolute value of x has to be greater than 2, right? Greater than or equal to 2. This is the point in math where you have to think. You have to get a conceptual understanding. Do you understand why this is distance from 0 essentially? And the absolute value of x is thus greater than or equal to 2. And don't forget our other condition, x can't be equal to -3. So D would be the correct answer, I believe, Alina. Is that correct? Okay, good.
That's D.
Perfect. All right. And once again, I'm going to keep reminding this because I feel like I should. We're working this out so you understand it, but in the exam, you should do this in your head as much as possible. Okay. All right. Who wants to try number 4? Anyone? All right, that's fine. I'll talk about it. So number 4, let's see. We're taking the natural log of x minus the natural log of 1 over x, and that equals +2. Then x equals what? Okay, so I know that when I have two logs separated out, that's essentially dividing, right? And I know, or the other way I can think about it is that this is a -1. I can raise this whole thing, whatever's inside here, to the -1 power, and that makes it natural log of x instead of natural log of 1 over x. This is just saying the natural log of x plus the natural log of x, which is essentially natural log of x squared. And if that equals 2, what this is saying is e to the 2 power equals x squared. That means x must equal e. That means C is the answer. Is that correct, Alina? Okay, good. All right. All right, let's do the next one. It's funny how we haven't even gotten to calculus yet, but this stuff is actually pretty difficult conceptually thinking. And that's what a lot of the AP Calc exam will actually test you on. A lot of it is just conceptual, even though it's not pure calculus. Okay, all right. This is good. But I feel like this is good review. Do you guys remember how to take inverses? Someone want to walk us through this?
You switch x and f of x, and
Exactly.
then you revert it.
So okay, so then that means that'll be, we'll have x equals f inverse of x over f inverse of x plus 1, meaning we have to multiply this out, and essentially this will be f inverse of x times x but I'm going to skip a step, and I'm going to know that I'll have to subtract that. That'll be x minus 1 plus x, and that'll equal 0. If you're confused about what I just did there, go ahead and work it out. I just did this in my head. So what I did was I took this, I distributed it out because I'm multiplying it on both sides. So I'll get f inverse of x plus x, and then I subtract the f inverse of x from this side. So then I factor out the f inverse of x, and now I can isolate it, and this will be f inverse of x equals negative x over x minus 1, and we can just make it equal to one of these. We can say it's positive x over 1 minus x. So it should be C. Okay. Is it C? Okay. All right. Does this make sense what I did here? This is the type of mental work that I'm talking about. You need to be able to go from here directly to here. And it takes practice. You've got to work on it. It's not something that anyone should expect you to do immediately. Like that's insane. No one should be able to do that. And if they are, then they're a genius, and I envy them. But this takes lots and lots of practice. You just got to be able to look at that and think 2 steps ahead about what you're going to do. Okay. Once again, feel free to interrupt me if you have questions. Even when I'm in the middle of working problems, I don't get offended by that at all. In fact, I'd rather appreciate that. Which of the following does not have a period of pi? Okay, so when we have, let's just remind ourselves, when we have sine of x, this has a period of 2 pi. Correct me if I'm mistaken. It has a period of 2 pi, right? Okay, so if it has a period of 2 pi, if I take sine of half x, okay, so if I have f of x equals tan of x, that has a,
what about me?
oh yeah, that's fine, Alina. Sorry about that. Okay, so what I was saying was, how can we do this? Anyone have any idea on how we can approach this one? Well, what about tan of x? Tan of x looks like that, right? This is a tough one. I don't know how to think about this conceptually at the moment. I guess the easiest thing at this point, if you're like completely lost, then to save time, if you just don't know, then just plug it into your calculator. That's the best option I have at this point, because honestly, I don't know. So the first one is sine of half x.
Wait, could it be the absolute value one? Because it can't be
This one, that's
negative?
what I was kind of thinking. But let's just plot that out, because I can't visualize that in my mind right now. The absolute value of the sine of x, right? This one actually does have a period of pi. You see that, Neha?
Oh, I was looking at it as 2 pi. I misread the question.
Okay, okay.
But then wouldn't it be? Wait,
Wait, it would be sine of half x, right? Yeah, it would be sine of half x.
Okay.
Because, okay.
Yeah, because sine has a period of 2 pi. So
Exactly, sine has a period of 2 pi, and if I take half x, that's a horizontal stretch, right? Right?
yeah.
Oh God, I forgot how these things work. Okay. Yeah, it is a horizontal stretch. Sorry about that. I just forgot about that. So yes, so half x would be the answer for this one, I guess. Okay, so then that would be A. Okay. The next few are, I want to skip the next few just because I want to get to some of the calculus so we can actually review some of that stuff. That'll probably be more on the test. Let's try something like, we need to get to the end of this. Let's start around number 56 with your permission. Is that all right? Okay.
How many of these are you going to do for
I'm
practice?
gonna do all of them.
There's so
personally.
many though.
There are a lot, but I'm just gonna do them. Okay. Do we want to start around 56 or do we want to start around here? Let's start around here maybe. Yeah, let's start here. All right. So if f and g are twice differentiable, and if h of x equals f of g of x, then h double prime of x. Okay. So the first thing is, what is h prime of x? Can someone walk me through that? What would h prime of x be? If you've already spoken, that's completely fine. You can speak again. Go ahead, Zachary. Did you want to say something? All right. Wait, can you guys hear me? Okay. Does anyone know how to do h of x? What would h of x be? Anyone?
Wait, so with chain rule, it would just be like f prime of g of x times g prime of x?
Exactly. Good.
All right.
Now, Anish, go ahead and try and walk me through the second step. So if I wanted to take h double prime of x, what would I do? This becomes a fun problem. All right, what do you have to do now? You have to do chain rule and product rule, right? Because you have this times this. So what would it be? It would be the derivative of the first one, right? What would the derivative of this be?
So derivative of first one would be f double prime of g of x, or of g of x times g prime of x.
But then we have another g prime of x, so it becomes g prime of x squared, right?
Oh, if you just wanted to like simplify.
Yeah.
Oh, okay.
And then plus the derivative of the second one, which is
g double prime x.
And I'll just write that to the side so I can write this first, and that would just be f prime of g of x.
Yeah.
All right, so what's our answer? A, right? A is our answer?
Yep.
Okay, good. Okay.
So do you think this test will have anything from the previous one?
I think it will. I feel like it will.
Okay. So we have to review all that then.
The reason I say that is because calculus as a subject in and of itself is cumulative. Without the first concept, the second concept doesn't exist. Like implicit differentiation is just chain rule.
I just don't like limits. Like it's probably my least favorite.
I feel like limits won't be on there. I don't think limits will be on
Okay,
there.
that's
I
what I
don't
was
think
talking
that
about
far back.
then.
Maybe not. But
That's what I was talking about when I meant like the previous test. Like I don't want to like do limits again. I don't know.
But then again, I'm not sure. So if you want to be safe, you might want to study it. I don't know. Okay, for this one, what is the derivative of this one? This one you should be able to do just right off the top of your head. Anyone, just blur it up. To the x, what would that be? The derivative of that. Krishna, you want to try this one? Krishna, Karan, anyone? Yeah, go ahead, Krishna. Did you want to say something? Go ahead.
Oh no, I was just saying like I don't understand where the what you call it natural log comes in, so I really don't know.
Okay. So this is just one of your derivative rules. If you have a to the x, the derivative of that is a to the x ln a. Because why? Because if you have e to the x, its derivative is itself e to the x. But when we have a to the x, it's a special case of that, so it becomes ln a. So C is the correct answer. Right? This is just one of the rules you have to memorize. It's on that sheet, I think. So you should be able to find it. All right, what about this one right here? Number 55. This one is another one you should be able to try and just think through in your mind. Does anyone want to try it? Actually, I can't find the correct answer.
I think it's A.
You think it's A?
Yeah, because I think ln of x would
sorry.
be
You're right. I didn't see the ln. Yeah. Okay, then it would be 1 over 1 minus x. But then here's the problem, though. You need to do the chain rule, right? What's the derivative of the inside function? The derivative of the inside function is negative 1 minus x to the negative 2 power, but then the derivative of that inside function is negative 1, so that becomes a positive. So we get 1 over 1 minus x. Wait, no. Hold on. This shouldn't be 1 minus x. This should be 1 minus, or this shouldn't be 1 over 1 minus x. This is just 1 minus x, right?
Yeah, that's right. Yeah.
Okay, 1 minus x. But then we have to multiply that by the derivative of the inside, which is negative 1 minus x to the negative 2 power, but the negative comes out, so then that's times 1 over 1 minus x squared. And then that, yeah, you're right, it is A. Okay, does everyone understand how we got to A? Does that make sense? All right, I think we're good to go. Okay. If you guys don't mind, could you guys turn your cameras on? I mean, that way we can just, unless you can't, that's fine. That way we can just, I just feel like it's more interactive when we do, if we can see each other. The next one, f of x equals x times ln x squared. Who wants to try this one? Rishi, why don't you try this one?
So first you would probably do the product rule.
Yeah.
So that would be 1. It would be 1 times natural log of x squared plus natural log of, so 1 plus 1 over x squared times x.
Times 2x times x, right? Chain rule?
Times x, yeah.
So 2x, yeah. So 2x over x squared will cancel, and you'll get 2 over x. But then we multiply that x, so then these cancel. So we get ln x squared plus 2.
Plus 2. Okay.
Do you see how quickly we can do that?
Yeah.
So that's the speed we're aiming for. All right.
Yeah.
So I think the answer would be B there. All right. What about 57? Krishna, try 57. Just try it. Wherever you get stuck, I'll help you.
Okay, so first you do chain rule, right? And then then it would be sorry, I'm blinking.
So what's the derivative of ln of something inside? 1 over, right? The derivative of the natural log of something is 1 over that something. But then using chain rule, what do you get for the next part?
then you would do 1/2 x to the negative 1/2.
Okay, so 1/2 x to the negative. Okay, good. But now they want us to find f double prime of x, not just f prime of x. So this, if I simplify this out, what is this? This is just 1 over 2x, right? Because the square root of x times the square root of x is just x. So if I take 1 over 2x and I take its derivative again, rather than looking at it as 1 over something, I'm going to look at it as 2x to the negative 1 power. Now, what would be the derivative of this?
That would be -1, so negative 2x to the power of -2.
Negative,
right?
parentheses 2x to the power of -2 times what?
Times 2.
Times 2, exactly. Exactly. So now let's go ahead and write this neatly. It's -2 over 4x squared, right? And then the 2's cancel, and we get or the 2 and the 4 cancel, and we get a 2 here. This is essentially -1 over 2x squared. That would be B. Okay? All right. 58. Actually, I think that's enough of these types of problems for now. Okay. Let's try another fun one. Number 66. All right, for number 66, this one requires a little special trick. You guys know how to do this? We haven't learned it yet, so I don't think you would know, but if you do, please share. Okay, so Gautam, what's the problem with this right now? If I try and take the derivative of this, what's the issue that I run into?
If you try and take the derivative of this,
see, I know how to take a to the x power, and I know how to take sine of x, but I don't know how to take a combination of two functions. Like, that's really weird. How does that work? So if only there's a way to make an exponent disappear and bring it out front. And the trick we use for that is using logarithmic differentiation. So what I'm going to do is for y equals sine of x to the x power, I'm going to take the I'm going to take the natural log of both sides. Natural log of y equals natural log of sine of x to the x power. Now, the special thing about logarithms is if I have an exponent, I can bring this exponent out front. This is equal to x times the natural log of sine of x. So now what I can do is I know that I can differentiate both sides. So what would be the derivative of the left side, Gautam? Just natural log of y. What's the derivative of that?
1 over y?
1 over y prime, right? Because I have to differentiate that. And then here we have to use the product rule, so, and the chain rule. So what would this be?
Hold on 1 second. Let me write this down. Where's the paper?
So this would be the derivative of the first function times the second function, right?
Mm-hmm.
Second function is natural log of sine of x.
Wouldn't
Plus,
the second function be natural log sine of x, or would it be just sine of x?
Yeah, it's natural log of sine of x, yeah.
Okay.
So it's natural log of sine of x plus, what's the derivative of the second function?
1 over sine of x?
1 over sine of x, but then chain rule, and then what do we get for the derivative of the inside function?
Negative cosine x, was it?
Just cos x.
Just cosine x, okay.
Yes, just cos x, and then we multiply x. Okay. Now the way they've written it, okay, so we now need to solve for y prime. So to solve for y prime, we just multiply both sides by y. That means y prime, and what was y? Y was sine of x to the x. So I can just take y prime equals sine of x to the x power times everything I just put here, and I can just plug that in. and it's essentially natural. So it needs to start off with sine of x to the x. All right, so it's C is automatically, well, it's not automatically gone yet. But C is probably not the answer. Sine of x times to the x times, I think the answer is E. Because we have our ln of sine of x here, and then we have cos x over sine x is cot x, and then the x that's left over is here. That's why the answer is E. You guys see that? Okay. Good, and this was number 66? Okay. That one was a pretty, you'd have to think through that one a little bit. Okay. We have less than a minute in this session, so do you guys want to rejoin? Do you guys want to keep doing problems, or do you guys want to head out? Find a hunger. I'll keep it going if you have questions, but if you need to head out, that's completely fine. All right. More, please. Okay, we can do more. All right.
MG, are you gonna record the next session as well?
Yeah, I'll record all. I'll record both and put them on YouTube.
Okay. All right.
Okay.
Thank you.
All right. I'm just gonna end this meeting.